Today, we will be talking about the abstract factory design pattern. The abstract factory pattern, like many other design patterns, is designed to solve a problem that is often encountered during software development in the real world. The problem goes as follows. Suppose you have a distinct group of items or objects. Then suppose you have multiple groups of these items. You can call these groups families that can contain these objects. We want to be able to create these objects, but have them relate to the family that we specify them to be. But we want to do this all with clean code, and we want to make sure we follow these solid principles when solving this problem. Also, we want to extend the functionality of our application without needing to change existing code, such as adding new items. What should we do? Perhaps the factory method would be useful here. The solution is actually the abstract factory pattern. It is a creational pattern that is often known as a factory of factories. It is a way for objects that belong to different families to be created without specifying their concrete classes. The abstract factory pattern sounds similar to the factory method pattern. That's because it's actually an extension of the factory method pattern. It allows the reuse of factories and it increases the level of abstraction. This supports the open-close principle as it allows for new families and items to be added without needing to change the methods affecting existing families and items, something the factory method itself would not actually be able to do. Additionally, the abstract factory pattern supports the single responsibility principle, as the creation of objects is handled by the abstract factory rather than by the client classes. All of that might sound confusing to you, so let's present a real-world example that models the abstract factory pattern. Let's create a computer. We'll need parts of a computer in order to make a computer. Abstractionally speaking, the parts of a computer are the same between multiple computers. Each computer has a monitor, keyboard, mouse, CPU, GPU, etc. However, these parts can be manufactured by various manufacturers. Thus, each part comes from a family of parts made by each manufacturer. For example, monitors can be manufactured by Dell, HP, Lenovo, etc. CPUs can be manufactured by Intel and AMD. GPUs can be manufactured by NVIDIA and AMD. Thus, we can create our own computer using each of these types of parts, but each of them can be made by various manufacturers. We could have a factory method that each manufacturer implements to create its parts, but if a manufacturer wants to make more parts, then the whole factory method needs to be opened and modified to support a new part. This violates the open-close principle as we want to only extend functionality without possibly affecting existing functionality. Instead, we can avoid this by having an abstract factory that lists the creational methods for each type of part. Each manufacturer can then have their own concrete factory that implements the abstract factory to create its concrete parts. Thus, we are now able to have manufacturers that can manufacture their own parts. We, the computer builder, can now simply specify any parts we want, and the manufacturers will be able to deliver us those specific parts. To use the abstract factory pattern, start off with a list of abstract objects and families for these abstract objects. Specify concrete classes from the abstract objects for each of the families. Now we have the concrete objects that we need to be able to create. Create an abstract factory class that lists the creational methods of a concrete factory. Each of these methods map to each abstract object. Then for each family of objects, have a concrete factory that implements the methods of the abstract factory class. Each concrete factory will produce each of the abstract objects, and specify them to the family that the abstract object is for, thus creating the concrete version of that abstract object. The result is concrete factories, which implement the abstract factory that create concrete versions of the abstract objects for each family.
Now we will talk about the UML diagram template. Here we can see that the abstract factory is an abstract class, and its classes that inherit from it will have to overwrite the create product A and create product B methods, which is exactly what these concrete factory classes will be doing. And concrete factory 1 will be making objects of the class type concrete product A1 and concrete product B1. Meanwhile, concrete factory 2 will be making objects of the class type concrete product A2 and concrete product B2. Now both concrete product A1 and concrete product A2, these classes both inherit from the interface product A, and concrete product B1 and concrete product B2 both inherit from the interface product B. Before we walk into our Java code example that I have written to demonstrate the abstract factory design pattern, I'd like to quickly give you an overview of the UML diagram for that specific code. So here the abstract class will be company, and Microsoft and Apple will be the classes that inherit from it and specifically overwrite the create computer and create headphones methods. And we can see that both these methods will be returning the object of type computer and headphones respectively, and the specific products Surface Pro and MacBook Pro and Surface headphones and AirPods Max, they inherit from their respective interfaces. And finally, both the computer and the headphones interface, they both are required to implement this specific product interface. So they will have to overwrite and actually implement the method build in the actual classes, the four specific product classes. Here's a link to the GitHub with my code. I will demonstrate it working in Eclipse. So here we can see a working code example with the abstract factory design pattern, and the abstract factory is going to be company, with the specific concrete factories being Microsoft and Apple, and they will be making two types of products, computer and headphones, which both are interfaces that implement the generic product interface. So you can add more products if you wanted, and you can also add more companies if you want. And create computer and create headphones are the methods being overwritten, and in the product specifically, the build method is being overwritten. So now we can take a look at the actual code files. This is the Apple file and this is the Microsoft file. So as previously discussed, they both overwrite the create headphones and the create computer from the abstract factory class. And in the products class, you can see the generic product interface here, where build in both the computer and headphones interface will be overwritten by the AirPods Max along with the Surface headphones file and Surface Pro and MacBook Pro, with the printlns indicating exactly what kind of product is being made.
After learning all about the abstract factory pattern, we should ask, when do we use the design pattern? The main application of the abstract factory pattern is for a situation where you have various families of objects. You don't want the creation of the objects to be dependent on the concrete implementation for each family. An abstract factory would be best here, as the client won't know which family it will need to work with until runtime, and thus the abstract factory will be able to provide whatever object the client specifies at runtime. Additionally, if you already have multiple factory methods in a class, consider extending this functionality to a single abstract factory class that takes on the responsibility of creation, which supports the single responsibility principle. After creating and supporting an abstract factory, you are now free to extend the creational functionality of your application by adding new families and objects without affecting existing families and objects. This supports the open-close principle. The main benefits of the abstract factory pattern are that creation is only handled by one class, which is the abstract factory itself, and that the code can be extended without modifying any existing code. To extend the code to support new families and objects, the abstract factory itself can be extended to support new abstract objects and to support new families. Simply, a new concrete factory that implements the methods of the abstract factory can be added for each new family. Additional benefits are that the client is only exposed to the abstract interface, the abstract factory itself, so there is no need to depend on concrete classes, and that objects created by the same factory are guaranteed to be compatible with each other. The big drawback with implementing the abstract factory pattern is how easy it is for the complexity of the application to increase as the amount of abstraction increases. For each new family and new object added, the abstract factory interface needs to be extended, a new interface for the new object needs to be created, and new classes for the concrete implementations of each abstract class for the new family, along with a concrete factory for those concrete classes need to be created. As such, the code can become increasingly complex with an increasing amount of interfaces and classes.